Hello students, today we are going to discuss about 4th unit from digital communication. So the topic is digital modulation schemes. The course outcome of 4th unit is analyze the spectral characteristics and bit error rate performance of digital modulation techniques. In this, various digital modulation techniques are going to be discussed. Their spectral characteristics and bit error rate are going to be obtained. The first topic is passband transmission. So this is the block diagram of a digital modulation scheme. So this block diagram consists of 3 major blocks in the transmitter side. Similarly, 2 major blocks in the receiver side. First, we are giving the digital data to the source encoder. Then the information is modulated in the modulator with help of local carrier oscillator, and the modulated waveform is transmitted through the channel. So this channel may be wired or wireless medium. Along with the information modulated signal, noise can be interfered. So this is the transmitter block. So the message from the channel is considered as the input for the detector in the receiver section. So the major function of detector is demodulation. So detection or demodulation is nothing but recovering the original data from the modulated waveform. So decoder is a circuit. There we can produce the demodulated signal in terms of digital form. Then again that digital signals are going to be obtained in the analog manner, that is done in this decoder part. Then finally we can receive the demodulated signal, that is our original signal, either in analog form or a digital form. Here we are discussing about digital continuous wave modulation. So the input data here we have taken as binary bits. So the estimated transmitted signal is also again a data, that is binary data. So this is the operation of passband data transmission system. The types of passband transmission. We can classify the transmission by 2. One is coherent or synchronous transmission, and another method is non-coherent, or we can call it as envelope transmission. So in coherent or synchronous transmission, both transmitter and receiver are synchronized. Non-coherent or envelope transmission, by the envelope we can recover our original signal. When compared with coherent reduction, it is a simple method, but there is a high probability of error during the transmission. So these are the 2 passband transmission. The techniques used in digital modulation schemes. Major classifications are ASK, PSK and FSK. So that is amplitude shift keying, frequency shift keying and phase shift keying. So what is amplitude shift keying? Digital data modulates amplitude of the carrier. Frequency shift keying, digital data modulates the frequency of the carrier. Phase shift keying, digital data modulates the phase of the carrier. So in the digital communication, we will be focusing on frequency shift keying and phase shift keying. So this is general representation, graphical representation of these 3 techniques, ASK, FSK and PSK. Amplitude shift keying for each binary data. The binary data may be either 1 or 0. For 1, the corresponding amplitude of the carrier is transmitted. For 0, there won't be no transmission. Similarly, for 1, the corresponding amplitude of the carrier is transmitted. Similarly, for 0, there is no data. So this is on-off keying, which means for 1 bit or a binary symbol 1, the corresponding data is transmitted. For 0, it is going to be off condition, there will be no transmission. Then the next method is frequency shift keying. In frequency shift keying, there are two frequencies are going to be considered. One for binary bit 1 and another frequency for binary bit 0. Probably we will be considering high frequency signal for bit 1 and low frequency for 0. So for bit 1 here we have high frequency signal. For 0 here we get low frequency. So only two frequencies are shifted. Then the third technique is phase shift keying. So as we discussed earlier, two binary datas, one is binary 1 and another one is binary 0. For bit 1 there is no phase shift, so whatever the input, that is going to be transmitted. For 0 bit there is a phase shift between the previous one. So here the phase shift is introduced. 180-degree phase shift is introduced for 0. So wherever we are finding the levels, that is binary bit 1 and 0, there we can identify the phase shift. So here the input data is 1 1, so there is no change in the phase, so the same data are transmitted. Here we have 0, so 0 there is a phase shift. So here bit reversal is obtained. So this is the general representation of shift keying. Then advantages of passband transmitted over baseband transmission. One is long distance communication, multiplexing. It can be sent as a radio signal. Passband reads fiber optical coaxial cable. There is no intersimple interference or crosstalk obtained with help of the shift keying methods. Many modulation schemes are available based upon the MRI. Many analog channels are also available. So these are all the advantages of passband transmission over baseband transmission. The drawback, the major drawback is equipment cost design. The equipment is complex, so more cost requirement. Then it is not suitable for short distance communication. Thank you.